question number 15, it's a question of higher order equations. So if you understand quadratic equations wherein there are formulas for the sum of the roots and the product of the roots, the similar case you may write the formulas for sum of the roots taken one root at a time, sum of the roots taking two roots at a time, and then product of the roots for a cubic equation. Okay. So if I say that a cubic equation is ax cube in general, ax cube plus bx square plus cx plus d. Okay, here the coefficients are different. Okay, so you'll have to be careful. A is 1 in the above equation. If this is the cubic equation and alpha, beta and gamma are the roots of this equation, then I can say that sum of the roots alpha plus beta plus gamma will be equal to minus b upon a. Sum of the roots taking two roots at a time, that means alpha into beta. So sum of the roots taking the product of roots. Okay. So alpha beta, beta gamma and gamma alpha. This is equal to c upon a. And taking all roots at a time, that means product of the roots will be equal to minus b upon a. Okay. So these are the three formulas for the cubic equation I will use in this question. Okay. So let's have a look at this. So the roots of the equation x cube plus bx square plus cx plus d equal to 0 are in arithmetic progression with a common difference of 6. So let me assume the roots as a plus 6 and a plus 12. Okay. And the value of b is minus 33. The value of b is given as minus 33. Okay. So I can say that sum of the roots will be equal to minus b upon a. The value of b is minus 33. So minus of minus 33, that is plus 33 divided by a, which is 1. So sum of the roots is equal to 33. I will substitute it here for sum of the roots, which I have assumed as a plus 6 and a plus 12 because the common difference was 6 among the roots. So this is equal to 33. And the value of a can be obtained from here. So the value of a will be equal to 5. So if the value of a is 5, the roots of this equation will be 5, 11 and 17. These are the three roots of this equation. We already have the value of b, which is minus 33. Okay. We have to find out the value of c and d, and then we'll be able to find out the value of b plus c plus d. Alright. Okay. Now, okay. So let us now look at some of the roots taking two roots at a time. Okay. So some of the roots taking two roots at a time will be 5 into 11 plus 11 into 17 plus 5 into 17. And that will be equal to c upon a. Now c upon a, the value of a is 1, so this will be equal to c. So from here I can get the value of c. Okay. So the value of c will be 55 plus 187 plus 85. That is the value of c. So here c will be equal to 130, 140, 327. This is the value of c. Now similarly, I'll get the value of d. Okay. So for d, I'll look at the product of the roots, which is 5 into 11 into 17. And that will be equal to minus d upon a. A is 1, so this will be equal to minus d. 11 into 5 is 55 and 17 in दोनों को multiply कर लेते हैं. 17 into 11 is 187. 187 multiplied by 5. So that will be 935. So here the value of d will be equal to minus 935. Okay. So b is minus 33, c is 327 and d is minus 935. If I'll add these three, I'll get the value of the expression b plus c plus d. Alright. So b plus c plus d, calculate कर लेते हैं. So minus 33 and minus 935 is minus 968 plus 327. That is equal to minus 641. So minus 641, that is option B will be the correct answer for this question. Okay.